Good morning, ladies and gentlemen. Today we're going to be looking at solving equations with variables on both sides. So if you remember on our previous discussion, we do need to look for combining like terms. And then of course we're going to also go ahead and use our two steps, add, subtract, multiply, divide. But again, the small difference today is variables are on both sides. So we might still have to use distributive property. We might still have to go ahead and combine like terms. But at the very end, we have our variables on both sides. So we'll discuss that information just like we did back in August. So starting off with some sample problems. Again, these are not directly from your homework. But if you notice the left side, there's nothing I can really do there. But on the right side, I can combine my like terms, which is the variables. So I've got a negative 1p and a negative 2p. So rewriting that, I now have 13 subtract 4p is equal to 6, and then that's subtract 3p. Or you could write it as a negative 3p plus 6, and that would be acceptable as well. All right, when we are at this point here, there's a few ways to try and think about it, but the way that I have my students do it is I ask them to think about the smallest variable and then move that smallest variable. It's kind of like the idea of what's easier to bring in when you bring in the groceries. Maybe you're still allowed to bring in those groceries, maybe not. But again, when you helped, you always, being teenagers, decided to take the eggs and the bread, always the lightest stuff, the easiest stuff to move. And that thought with our variables is that negative 4 is technically smaller, lighter than negative 3. So I'm going to go ahead and add 4p to both sides. Now, the reason I've asked my students to think about it this way is because we know that many 8th graders still make mistakes with those negative signs. So this is one strategy to try and limit the amount of negative signs that you have. So I have, look at this, 13, which is positive, 6, which is positive, and then negative 3 plus 4 is positive 1p, or just plus p. I, as a picky math teacher, like to always have the variable on the left and then the other number on the right when I'm talking about my answer form. So I've asked my students just go ahead and do a little small movement and put the 13 over here and then lightly cross that off. So now I have 6 plus p equals 13. All I have to do is subtract 6 on both sides. So that will give me p is equal to 7. All right, so we combined like terms, moved the smallest variable, and then solved it. Let's try this one here. Now, just to give you a heads up, sometimes we might have special answers, and this is kind of one of those problems that will be leading to that. But before I get there, I want to go ahead and look at the left side and combine my like terms. If you notice, I have the non-variable numbers here, just my basic integers. So I really have negative 12 plus 5, because again, this is going to be our 1 plus 4 is 5, negative 12 plus 5. So I've got negative 7x, and then I've got a subtract 7. Oh, wait a minute, look at this. Isn't it the exact same thing? Aren't those identical, or called an identity? So we can go ahead and confirm that by realizing, you know what, the variables are exactly the same. So that means if I move them, technically they disappear. And I now have it into the form of negative 7 is equal to negative 7, which is a true statement. It's an identity, identical information. And we have a few different ways to describe this answer. Sometimes, maybe in high school, you might see this written as all real numbers, which means fractions, decimals, roots, all those different things would work for the value of x. The way that we primarily did it in 8th grade is that there are infinitely many solutions. And that was kind of listed a little bit more towards when we were doing our graphing skills. But I think both would be acceptable in this point. Really, it just means that a lot of answers for x would work. All right, on this one here, we're going to go ahead and practice our distributive property. So we've got 4 times 3, which is a simple 12, and 4 multiplied by negative 5x is a negative 20x. Now you may be noticing, Mr. Murillo, I have my x's the same, but my numbers, these integers, are not the same. So what am I supposed to do there? Well, we asked you, again, to continue on to be able to get that comparison, if you will. So if I add my 20x to both sides, I'm going to have a negative 23 is equal to positive 12. And as we know, with our basic understanding of numbers, this is not true. And that's when we ask you to go ahead and slash out the equal sign. Not true, or better yet, no solution. Which again means that there is no value for x that I could substitute for the original problem that would give me a true statement. I would never be able to get 5 equals 5, 6 equals 6, because I would always have it off like this. Negative 23 cannot equal 12. No solution answer. So we got two special answers. Infinitely many solutions, or all real numbers, no solution, and then again we can have one answer, which is like what we had here for our first problem. So let's try one more, and then we'll talk about our fraction skills. Now, if you notice on this one here, you've got several skills that you need to put together. Distributive property on both sides of the equation. You need to go ahead and combine like terms on most likely both sides of the equation. Then we got to get back to our variables on both sides. So again, just combination of everything. So I'm going to ask you to go ahead and think about it. What do I need to do? Let's go ahead and write our equal sign. Let's start on the left side. Let's see. Negative 4 times 1, negative 4. Negative 4 times 4x, negative 16x, and then negative 4 here. Okay, I can go ahead and finish this left side. Some students like doing that. So I'm going to go ahead and box, circle, triangle my like terms. Negative 16 stays the same. Now be really careful here with a negative 4 and a negative 4. Some students would say that they cross each other out, cancel each other out. But remember, that's when the signs are opposite. A negative 4 and positive 4 gives you a 0. But a negative 4 and a negative 4 gives us negative 8. All right, on this side here, the negative 8x gets to stay the same. And then we've got 7 times 4, which is 28. And 7 times negative 2x, which is negative 14x. All right, combine your like terms. This time the 28 gets to stay the same. So I've got a negative 8x and a negative 14x, which is going to give me a negative 22x. All right, now we're kind of like back here at the first problem. We need to decide which variable is smaller. Because again, I like moving the smaller variable. So negative 16x or negative 22x? Yes, correct. So I'm going to go ahead and add 22x to both sides. This is going to give me 6x subtract 8 is equal to 28. All right, we now have it down to our two-step problem. I'm going to go ahead and add 8 on both sides, and it's going to give me a nice normal answer. It's going to give me one solution. You had questions like that on quizzes and tests, specifically later on in Chapter 5. You know, how many answers would you get? How many solutions would you get? One solution, two solutions, infinitely many solutions, or no solution. So x is equal to 6. Beautiful, beautiful. All right, last discussion piece, because I see that you have this on Wednesday's assignment. Just quick discussion again with using your distributive property with fractions. So when we multiply here, we've got two strategies that we ask our students to do. One is a little bit of mental math. The other one is handwritten. So over here, like in the margin, you would say 2/3 multiplied by 6/1. And you would practice your cross-canceling skills. So a 3 becomes a 1, and a 6 becomes a 2. Or, for those of you who like preferring a little bit more mental math, you could do 2 times 6, divide by 3. 2 times 6 is 12, divide by 3, still gives me the exact answer, 4x. Let's try the second idea. It is definitely going to be a subtraction or a negative sign there. So again, two ways. You can write it as 2/3 multiplied by 9 over 1. I didn't worry about the negative sign. I already have it written there. So I can cross cancel, multiply, or I can multiply and then divide. Same answer. 3 becomes 1, 9 becomes 3, 2 times 3 is 6. 2 times 9 is 18. 18 divided by 3 is 6. So just because you see a fraction there, please don't freak out. And I even see one that there's a decimal of 0.5. So remember, if you have a 0.5, you could always change that to 1/2. And taking half of something for some students is a little bit easier than 0.5. All right, you're going to be awesome and do your best. Let's get ready for high school.